Okay, welcome to Extended Detection with Cisco XDR. We are starting on time, and we're ready to begin right after lunch. Okay, so as with every session, there is a WebEx Teams room. If you have questions you want to ask, after reflection, you're like, oh, this was really interesting, and you want to ask me questions, I'll answer them. I'll watch the room. However long it's open, I will keep monitoring it. Okay. So this session, it's our primary objective for the next hour is just to walk through what is Cisco XDR analytics engine, basically how we go from data through native detections and into an incident in the UI. And actually I'm going to start with the incident generation framework, where incidents come from, and we'll do native detections in kind of the second half of the hour. In a 1 hour session, there's a combination of deep and overview. So we'll kind of do overview, deep in certain areas, come back and go, and I'll hopefully, depending on how much I talk, try to get into demos towards the end so that we can actually see some of it in the UI, because it's a little bit better to see it in the UI as opposed to see it in screenshots. Okay, so it's mostly going to be incident generation framework followed by native detections. That's the objective for the next hour. If you have never come to a session with me before, my name is Matt. I am a distinguished engineer here at Cisco. I have been at Cisco for a very long time in a variety of different roles, predominantly technical marketing. I did go to Landcope. It's part of my 17 years for 2 years before I came back in. I am Canadian. That it's relevant because of certain jokes I make. That was me last week at my house. Okay, sorry, it wasn't last week. It was in February, but that's where I live, in the middle of a frozen lake all winter long. Okay. And just in case you didn't catch my references here, so we are at lunch, or just after lunch. It's 1 o'clock. So which means the sun is actually over the yard arm, which means you can choose whichever you want to do for drinking for the rest of the day. Okay, so what is Cisco XDR? If you're unfamiliar with Cisco XDR, this is our top level description of what it is. It is a collector of telemetry from multiple products. We apply analytics to that telemetry to arrive at a detection of maliciousness, and then we provide accelerated/guided response to that detection. Really straightforward in concept. There is a lot of details in that analytics engine on how we basically create those detections and what we call an incident. And I'll get to the definition of alerts versus incident in a second. Okay, so because XDR is actually a very involved product, there's a number of different ways of looking at it. The one thing that is true, if you actually look at the definition, it is centered on integrations. If you integrate nothing with XDR, it does nothing. It is a value proposition is entirely based on integrations, which you can break down into the pipeline in the middle, which is you have the integrations that help create incidents, you have the existence of an incident, and then you have integrations for response. And so here you have our 4 surfaces of integrations. There are 4: data analytics and correlation, threat hunting, investigation, automation and response, and asset insights and context, or what asset/user insights and context. And if you were at Oksana's session earlier this morning, she went through all the bits and pieces that kind of make up these different frameworks. This session is solely going to talk about the incident generation framework and the native detection engine, which is really only just this little box over here. Okay, so the incident generation framework. If you were not paying attention over the course of, I guess it's a little bit more than 6 months, it's about 9 months, 8 or 9 months now, we actually created the term incident generation framework around October of last year, and that's when we started calling it. On October 23rd, 2024, we actually published into production a substantial change to the incident generation framework. Before that, we called it attack chains. It was visible in the SCA UI and labeled as attack chains. After that, it became what we call the incident generation framework, and it is a substantial change, which largely what I'm going to talk about is how the incident generation framework works today before we get into native detections. So I'll start with the really high-level definition. What is an incident? So, my pipeline before, we had data comes into analytics. We create an object called an incident, and then you go to a response. An incident, functionally speaking, is a data object combining multiple pieces of related security information, allowing you to detect, triage, investigate, and respond all in one place. I actually went into the help file to actually find out what that definition really is. That's somewhere in help. But really, I added the part about data object. And the data object is key because that describes where it comes from. And today, in the XDR UI, an incident is stored in something that we call CTIM, which is the Cisco Threat Intelligence Module language, which describes basically the way an incident is kind of framed in a JSON format. And the way that it is written into the UI so that you can see it or into the incident store is via an API. Now, the incident generation framework calls into an API, or that public API you can also call yourself, which if you go to the Security Operations Center downstairs, or you look at different workflows, you'll see that there's people that are using that API to directly create incidents into the incident store. But mostly the API is there for workflows, custom integrations, or the incident generation framework, which calls it and creates that data object. Now, because it is relevant for the rest of the session, there are two UIs that you'll see screenshots from. So this is mostly an aside. There is what we call the main XDR user interface, which is the user interface that the analyst mostly is going to interact with. It is a SOC dashboard. They go in, they work the incident. That's largely what we're going to look at. However, the detection engine, which is still called Secure Cloud Analytics, but often we call it XDR Analytics, is a separate user interface still. We have not fully collapsed its user interface into XDR. And so we can look at the two user interfaces as the analyst user interface or SOC dashboard, and then the admin or detection engineering admin user interface for the analytics stack, which is formerly the Secure Cloud Analytics user interface. You'll notice that it just says, whenever you log into it, it says Secure Cloud Analytics, now part of Cisco XDR. Okay, and so that brings me to a distinction in terms. An incident is a data object that resides in the XDR user interface. And that is, logically speaking, it's what we'll call the extended, and I put in brackets, correlated detection, because correlation and enrichment are two different words in our vocabulary of what XDR does. We correlate data before we create an incident, and then we enrich it after the incident is created. The incident generation pipeline is centered around creating that correlated or extended detection, which becomes an incident, and it is made up of data that came into the product that has verdicts. On the other hand, the native detections is the detection system creating verdicts out of the data that comes in. And so I kind of listed examples of the different types of things. So an incident is largely made up of outputs of the native detection engine, data from things like integrated EDRs, email threat defense, SNA, et cetera, whereas a native detection is one in which we have taken in telemetry without verdicts and created a verdict using analytics. And so example data sets that we create verdicts out of are things like NetFlow, NVM, cloud logs. There's 3 ICE detections, data off of FTD. We can have an academic discussion about why FTD is over here in the native detection right now and not something that comes with verdicts that has to do with history, which is not going to be something we're going to talk about today. But as of right now, FTD data goes through the native detection engine before it arrives into an incident. There will be changes to that pipeline at some point in the future. But okay, so the whole objective of an incident generation is to aggregate and correlate artifacts from the integrated telemetry sources to logically speaking, what we want to do is recreate the timeline of a security event or security incident. Okay, so the incident generation framework looks something like this. It begins with the acquisition of data, so we acquire and normalize data. I put in highlighted here detection telemetry. The incident generation framework begins on data that has verdicts with it. We don't start correlating on raw telemetry like NetFlow. We start correlating on alerts. After we have acquired the data or the detection telemetry, we then do the aggregation and correlation. I'm going to walk through that in a couple slides. After we have aggregated and correlated, functionally speaking, that means the incident object has been created. Once the incident object is created, we then run a generative AI summarization process against that incident to attempt to put into natural language a description of what we have correlated together. After that is all done, we then do risk scoring and prioritization, which I will show in a future slide on how that's kind of computed. And then finally, the incident is, we call it promoted. This is when it is first visible in the user interface, is when an incident is promoted. And functionally speaking, from a technical standpoint, that means we hit the API and drop the CTIM bundle into the incident store so that the interface can see it. And after that is when enrichment happens. That's API-driven, ask integrated products, what else do you know about the data in this incident? And it comes into and joins with the rest of the data. Okay, so acquisition, normalization, fairly straightforward. We have integrations. It's a published integrations book somewhere that says these are all the integrated products that go into incident generation pipeline. So all these data sources with verdicts come in, we put it into what we call a data warehouse. We store data in the data warehouse. All of our detection sources is stored in the data warehouse in OCSF format. That's not that relevant other than when you look at the JSON in an incident, you can actually see how it's stored, which is in OCSF. Once it's there, the analytics then runs on it. So how do the analytics work and what do we do? So all of the detection findings land in the data warehouse. We then do a correlation and aggregation process. So aggregation happens first. What is aggregation? Aggregation is taking, we'll call it duplicative or repeat sightings of the same type and reducing them to a single finding. So for example, if you have a suspect data hoarding alarm from SNA that comes into XDR for a given host, and that host has multiple occurrences of the same alarm, we reduce them down into a single object through the process of aggregation. Multiple detections of the same type involving the same actor and observables are reduced into the same sighting. This is really, really common in EDRs where the same piece of malware is executed or loaded over and over again, and you see the same basically finding or detection over and over again. And so then we aggregate it down into one data object, which then becomes the thing, the aggregated object is the thing upon which we then start to correlate. Correlation is grouping related sightings together by common observables in the sightings. And so here is an example where on Monday, 192.168.130.12 with the host name Bob Wynn, had device ID of 11, had a file hash and the of 45ABE with Bob. Tuesday, we had a same IP address, the same username involved. We've also extended the attack chain or the correlated incident to include another IP address. And then on Wednesday, we see this IP address again, the same file hash here as back here on Monday, and then a different user. So ultimately, you end up with a story that has evolved through time. It says the incident began on Monday involving this IP address, this user, this file hash, with a final sighting on Wednesday involving the same malware executed on a different device. right? So they were largely correlating on noun data extracted from the sightings from the different aggregates. So the general correlation criteria, the sightings are correlated when they share at least one correlation observable. It is a 7-day rolling window of a correlation timeline currently. We've experimented with different timelines. If you are familiar with or experienced XDR when we first published it, we actually were doing an exceptionally long timeline, which we thought was kind of cool at the time, but it turns out that if we look backwards of 6 months of data and correlate everything together, if there's just one massive incident in some organizations, and that wasn't so cool. But it did help to find some really otherwise unrelated things. So as of right now, we're looking at a 7-day rolling window of correlation timeline, which means that we are looking across these current correlation observables: IP address, device name, host name, username, file and process hash, URL. If you see common ones of those across multiple sightings in that 7-day window, they get correlated together. Now, if an incident keeps living, so this is where the rolling window comes into play. If it keeps living, meaning there's still sightings for a given incident inside of a 7-day window, that window moves, and so you can have an incident that grows and continues to grow for months at a time. There are some safeguards around this. One is we don't want more than 10,000 sightings in a given incident. Sometimes this happens. And then 2K, we don't want more than 2,000 single entities per incident. Mostly this is to prevent blowing up of major components. We also don't correlate into a closed incident anymore. And reopen the incident. That caused some people grief. And so if the incident has been closed and the same observables, et cetera, show up again, even if it's the same sighting, it just becomes a new incident. Promotion criteria. So the incident, basically behind the scenes in the analytics engine. So anytime we're bringing in data, we're doing this process of building what we call the attack chain and putting the stuff together or correlating into an incident. An incident doesn't show up into the UI until it meets the promotion criteria, which means we have decided this is an incident, it shows up in the user interface. The primary rule that we had on XDR analytics for quite some time is it contains at least 2 different sightings of different detection sorts, detection type, different actor. SNA and ETD has a special bullet there, and I'm going to revisit that in a second. But the second thing that we've done is we've actually created, beginning October 23rd, 2024, single sighting incidents. So single sighting incidents are created if the source is an endpoint detection and response product, and the severity of that sighting is critical or high. We did add a guardrail around not having more than 10 single sighting incidents per day. At the time, we've reevaluated. We're looking at how that might actually change because some customers didn't like that and they wanted thousands, which defeated the purpose, but we're still looking at that. Okay, I said I'm going to revisit this one. So generally speaking, 2 different sightings of differing detection source, detection types, detection actor. So you could have, say, 2 SCA alerts based on flow data correlate together and create a sighting. This is, in fact, how attack chains started. We found that certain data sets, predominantly what that meant was SNA core engine events and sightings out of ETD, weren't of sufficient fidelity enough to create alerts based solely on themselves. And so the SNA core suspect data hoarding, suspect data loss, and command and control sightings need to correlate with a other detection source, and the same with an ETD sighting. There is no single sourced ETD events, for example, so they need to correlate with something else. And that's just mostly to prevent incidents that are otherwise non-descriptive enough or not descriptive enough in what they're doing. Okay, and I'll show, I believe I'll show a couple of those. Once the incident bundle object is created, is promoted, it has passed the thresholds for existence into the UI, the AI summarization puts into natural language the description of the incident through time. So the example here is actually, this was an incident that how long was this? It was only about a week. But basically, I'll have an example of this when we get to the demo. But the AI description has a long description, has a short description or summary description, and then a long description, which is basically walking through all of the incident, all of the components or sightings of the incident as it progressed through time. Once it has been summarized, and now, so the object exists, it's been summarized, we then compute a score for the incident. A score is made up of, and this, the prioritization score is made up of 3 metrics. The first one is the score that shows up in the UI, which is a score between, we always say between 0 and 1,000, but it's actually functionally impossible to have a score of 0 and show up in the UI. It has a score of 0 before it exists, but once it exists, it will always have a score above 0. And it is made up of a detection risk score, which is a function of largely the MITRE TTP financial risk, the number of MITRE TTPs involved, and the source severity involved. There is a lot of ongoing research that continually evolves and changes how the detection risk score comes up, but it is coming out of our an internal data model based on those 3 or a handful of other metrics that we've looked at. The thing that the user has control over is this one. So basically there's a detection risk score somewhere between 1 and 100 and an asset value score. The asset value is the thing that you can configure. By default, it is still set at 10. You can configure it in the Asset Insights page. We are looking at changing the default. There's lots of debate about this. You can debate on what the default should be all day, forever. Nobody has agreed on what it should be. We have some data that indicates if the default is 10, users are more likely to tune the system down to get the more value out of it. Lots of people argue the other way around, which is if the score is lower, we want to tune to get value. But anyway, as of right now, it is 10. We might change it at some point in time. But anyway, you can figure that on the Asset Insights page. That's one of your only levers for adjusting the value, the score of an incident, actually. Okay, so once an incident exists, the same algorithms that went through the creation of an incident continue to run. So that means an incident can be updated. So if new sightings show up that meet the correlation criteria that I discussed earlier, they will be added to the existing incidents. That's part of that rolling baseline. And so incidents can continue to be updated by having new sightings show up. They correlate to an existing incident. Also, existing incidents can merge together if they meet the correlation criteria that would create them to be the same incident. So if you have like incident 1, incident 2, and then some data shows up that's like, oh, hey, this new data that showed up logically makes these 2 disjoint incidents the same incident, they'll be correlated together. And I'm going to have a slide here, just a little bit of notes about how correlation works next. But before I get there, one thing that I have to call out is the title and description are actually also updated as an incident is updated. The thing about the AI summarization is that it will, as more data arrives, be able to better describe how the incident evolved through time, and that will actually change the title, and it will change the description. The only thing that doesn't change for that incident is the incident ID, which is a very long hash value that you can actually see in the UI as you link to that particular URL. That doesn't actually change. But anyway, the title and description are updated as an incident updated. And then this is my note here. I mentioned this already. Closed incidents are not updated. If you are basically like, I don't want this incident to change anymore, I will change its state on mark it as closed. We don't add data to it anymore. We used to, in the past, reopen incidents. I was talking to a customer the other day that was actually interested in this idea. They're like, what if the incident reoccurs in some time in the future? And like, well, we're not reopening automatically right now, but we are thinking about different ways we might bring context of a closed incident up to a current incident if they truly are related. Apparently, reopening something that was a closed ticket upsets some people that like to track metrics. Anyway, exactly. As much as we would like to, from a security standpoint, reopen them and go, hey, these are actually related, turns out that some people don't like having their work undone. Strange. Okay, and then incidents are not updated if there's been no update for the last 7 days. Even if it's marked as new, there hasn't been new data added to it for 7 days. If a new object shows up that actually would have correlated into it, it is not updated. It's treated like a closed incident. Like I said, we used to continually add to that, but turns out we just randomly chose 7 days and said, this is a reasonable timeline right now. There was a point where I was correlating backwards to 6 months, and I thought that was really awesome, but some people didn't like it. So right now we're looking at 7 days. Merging criteria. This is mostly for your reference. It logically makes sense when you look at how the merging happens. It's basically which is the oldest incident, and when new data shows up and how we move them. We do take state into account. It's open versus new, and then when we merge them, if you read the words and you look at how they merged the X's and lines between these cells, makes a lot of sense. The one note, I have to throw this out there because the API is there. If you directly create any incident via API or any incident that actually bypasses the incident generation framework, so this includes directly promoting native incidents or native detections, which is the next section, they will not be merged. We don't take an incident out of the UI that did not pass through the incident generation framework and then correlate on it. Those are treated on their own as of now. We have looking at ways we might change that part in the future. But as of right now, anything that's created directly via the API does not, or that did not come from the incident generation framework, does not get merged. Okay, so native detections. So far, I have talked about the incident generation framework, which works off of detection telemetry. So it's easiest to think about, or it's easier to think about the IGF in the context of it takes in detection telemetry and then creates a correlated incident. At the same time, we take in telemetry that does not have verdicts. We run analytics on that. We create an alert. This is basically the SCA process. And that alert object then gets picked up by the incident generation framework. So raw net flow, for example, does not suddenly get correlated into an incident. The alerts that the detection engine creates get correlated into an incident. So how does the native detection framework or native detection work? So this pipeline of data technically ends, you can see it over there on the right, at the pipeline of data I just talked about. So this pipeline of data, we acquire data, we put it into a data warehouse. Out of the data, we extract what we call an entity. This is logically a similar entity to what the IGF does, but it's an entity is a thing upon which we can make an observation, basically a noun. We have a handful of different things we define as nouns. We make an observation on the noun. Observations can go to alerts, and then alerts are the object that gets correlated into the incident generation framework. The observation to alert model is a holdover from the way SCA operated for years. I'm going to dig into that in a couple slides. Actually, I'll start here. Observations are like a low-level signal in the context of the secure cloud analytics engine. So the way I usually describe it is high fidelity, low noise was the major objective of the NetFlow analytics or flow data analytics engine in SCA. And the way that you get high fidelity, low noise is you filter noise through a probability model. So data comes in, observations are made. Observations are statements of facts. We saw a thing of interest. So say we're looking for a long-lived flow, we're looking for flows of repeated connections, so on down the line. There's quite a few different observations. On their own, these are low signal alerts, meaning the fact that a host has repeated connections every 5 minutes, it reaches out to the same server for the last 2 weeks. That's an observation, it's a statement of fact. We don't want to move it to an alert unless we're sure that it is a substantially security-related event that we want to move to an alert. And then so it passes through what we call the probability model. Probability that this is an alert, that this observation or set of observations is an alert, given everything we know about the host involved and the organization that we're monitoring, plus data we might take in from the fact that we monitor lots of different organizations. Eventually, an alert might show up, an alert then gets correlated into an incident. So you could actually logically think of it as data that has no verdict or no security intelligence associated to it, a low-level signal, a higher-level signal, and then the highest-level signal. So data in order to go from raw data to alerts, or rather for the analytics engine to extract security value out of raw data, we sometimes need certain sets of data. I have to get criticized for just saying this, but the most important thing you can actually do to familiarize yourself with how the analytics engine works is actually just go to the observation page and the alerts page and read how they actually work. There's descriptions here. It says what data it has, what data is required, what observations are required in order to make an alert happen. You know, it's a read the manual conversation. It is actually the easiest and quickest way to have an understanding about how the system works is to go to this page and look at it and what's there. So one note, and I called this out earlier. So generally speaking, the point of the incident generation framework is to take alerts, group them together to create value out of them. You can, however, treat native alerts as an end object on their own. There is an option in the UI to allow it to be, it says, there's a little radio button that just says Cisco XDR. This doesn't actually mean integrate it with Cisco XDR. It means create an incident directly out of this alert in the XDR UI. I have some customers that like to do this for alerts that they know to be important to them, that when they show up, they would like it to become an incident on its own. I know a lot of other customers that just went in and turned this radio button on because they thought it was a fun thing to do, and then that resulted in a large number of incidents because you've bypassed the incident generation framework, which is why I have this note that says use discretion. Sometimes it's really important. I mean, sometimes it's worthwhile. You know you have a certain type of alert that you would like to have an incident based on, but it can, in fact, become noisy. And also, it is definitely going to result in duplicative incidents because just because you promote an alert directly to the UI does not mean it won't go through the incident generation framework. It will go through the incident generation framework, and you could end up with 2 incidents instead of just 1. And then also they can be published into any other system. Native alerts can become their own thing. Okay. There are only 3 levers currently to allow for the tuning of native alerts. It's not a very we'll call it detection engineering friendly system. There's 3 levers, and they're blunt at best. And the reason we've done this is principles of the development for the native alerts was to go high fidelity, low noise, as discussed, but also to make it minimum tuning, easy to deploy, easy to use. And the more complications that you add to tuning, the more you get away from those principles. I will say that it would be nicer to have more tuning options, and we're looking at different ways of doing that while maintaining the easy to use, easy to deploy mindset. But as of right now, those are our 3 levers. So the first and probably most important is subnets and sensitivity setting, particularly for the flow-related events. If you want them to fire, it is important that you specify what your subnets are and what the sensitivity is for those subnets. Inside of the sensitivity settings, you can also set low, medium, low, normal, and high, but you can also set static and a new device alarm or alert, new device alert. Static just means hosts have the same IP address. It's not a DHCP scope, so we can allow slightly better baselining of individual hosts at that point. New device alerts is when there is a new IP address that shows up in this range, give me an alert. And then the other 2 settings, which is enable, disable, and alert priorities, those are the other levels. Priority is mostly an informational setting, so it's not that useful as a lever. And then enable, disable is the main lever that you get, which is turn an alert on or off. There are some alerts that in some environments can be fairly noisy. The recommendation then becomes turn it off. If you don't like it, turn it off. But that is the, and then the other thing about when we publish new alerts, generally speaking, an alert has 30-day-ish development cycle. So we go from concept to new alert in the portal, give or take 30 days, depending on how the research cycles work. We'll come up with concepts of alert, do the research, think about what it looks like based on the data that we have, implement it, test it out in the data that we have, go behind the scenes, go, okay, we're comfortable with the alert working, publish it out into the real world, and when we publish it out into the real world, meaning the customer, people are able to see its existence, it is by default off almost all of the time. We rarely publish one by default on. This has caused great consternation because we have added, in the last 6 months, we've added quite a few alarms, actually, quite a few alerts, about 60 or 70 different alerts, about 40-something plus NVM alerts have been published out in the last few months, and then by default they're all off, and everyone's like, why aren't these on? These would have been amazing if they were on. And I was like, well, you'd say something different if they all fired and you didn't like them. But basically we publish them on default off, you turn them on, we publish new alerts. They're roughly, generally speaking, because we do a bi-weekly release cycle, there is a new alert or more that do show up every 2 weeks. It's worth taking a look and seeing if they're on or off. Okay, so I'm going to dig into a couple different alert types. These are probably the ones that I consider to be some of the more exciting ones in us extracting value. Obviously, the cloud logs are a big deal as well, but I'm not going to get into those. So 2 of the major data sets that we often talk about that differentiate the value of Cisco XDR and what it's bringing is its ability to analyze network flow logs, otherwise known as NetFlow and IPFix, to extract or to create security value out of network behavioral conditions. And then the second one is the network visibility module from Cisco Secure Client. I mean, we talk a lot about the NVM detections because those are, when we launched XDR, it was a net new functionality that we didn't have in the portfolio. And it also enables some really cool data correlation as well as the native detections, which I'll talk to in a second. Okay, so network visibility module detections. I mentioned we published quite a few. Actually, as of when I took this screenshot last week, there were 61 different NVM alerts in the portal. A lot of those were published out in the last 2 quarters. We did some pretty extensive research, both with some customers, some red teams, some emulation testing to get up with different types of visibility. And the really unique value of what NVM detections are providing is detection. They're really, really useful for detecting living off the LAN binaries. And we can also say living off the LAN scripts, et cetera, but it's mostly a combination of a normal somewhat normal process that runs on an endpoint, making a network connection that is somewhat not normal. So that combination of network connection with endpoint data is where the uniqueness of NVM is coming in. It is really where the endpoint and the network meet together in terms of the data set. I mentioned correlation. When NVM, or when Cisco Secure Client, NVM module resides on an endpoint that also has a endpoint detection and response product, the fact that we're getting a log data that includes a endpoint ID in combination with network data allows us to easily identify network traffic from an endpoint or involving that endpoint and correlate it to the endpoint events from that data that may not actually have network data associated with them. Okay, so for one of my favorite NVM alerts that I use in a lot of demos, because firstly, it's really easy to trigger, and also really simple to explain. NVM is about bringing process and endpoint data, or process and network data together. So my favorite one to talk about is this PowerShell RDP connection. So PowerShell RDP connection, and actually if you go through a lot of sessions, then some of the slides will be like, XDR is really good at detecting things, like PowerShell made a odd connection. This is in fact that connection that people talk about all the time. It is simple to trigger in your environment if you want to test something. It's basically have PowerShell launch a TCP connection to some other server on TCP 3389, which is an RDP session. Basically, it's have PowerShell, launch a RDP connection to a RDP server. Pretty simple to do in your own lab, pretty simple to understand what it is. This is a non-normal use of a binary PowerShell that is normally in the environment, or is present on all Windows devices. Okay, and I'll show that one in a demo, I believe. Okay, so network flow log detections. This is where it gets a little bit more complex in terms of understanding how the detection system works. Network flow logs, or behavioral conditions, we take in large amounts of data, we profile an entity. When an entity does something that is different than normal, which is, from that set of observations, we create an alert. So data comes in, analytics happens, observations are made, observations are grouped together into the creation of an alert. And a really simple one, and I've used these examples for years, is about data movement. So if you have a malicious actor, this guy in the center here, he can go and connect into an important data repository. For example, this guy over on the far left has a collection of beer. And this malicious actor is like, well, I will take said beer, move it over to his own set of repository. That's called data hoarding. And then exfiltrate said data to an outside repository, and that is called data exfiltration. And so this is a really common behavioral condition upon which we have many algorithms that go and detect that. I'll show in examples. But different ways that we would look at doing that. Here's an example of a detection called an outbound traffic spike. Outbound traffic spike device, the description is here. It says device started sending a much larger amount of traffic to an external destination than before, may indicate data exfiltration. It is based on 3 different observation types. In order for this alert to fire, these observations need to happen, meaning we need to have a record profile outlier observation, a new large connection observation, and a record metric outlier observation. The history is roughly 14 days, which the history is a little bit misleading because some of these don't require history, some do. But then, history largely is what triggers on the probability model of the alert. And anytime you go from these observations, just getting these 3 observations to happen does not mean an alert will. It means we have these 3 observations together. It's have a 14-day worth of history. Then there is a question, given that these 3 observations have occurred and we know about this particular host, what is the probability that it is in fact an outbound traffic spike that has occurred? If we pass the probability threshold of that abnormally large amount of data being exfiltrated, we then would trigger the outbound traffic spike alert. This is, I do it, especially in red team exercises, I'll get on a lot of weird, or POVs, POCs, and small lab environments. I get into a lot of conversations of, I did this traffic flow, an abnormally large amount of data from an internal network client to external server. I didn't get this alarm, or I did get this alarm. And the I didn't get this alarm conversation is mostly a result of not passing the probability threshold. The system is built to be in a normal network environment as opposed to lab environments and/or requires a certain amount of time for baselining to occur. Okay, so I have another session on Wednesday where I talk a little bit, where actually it's entirely about secure network analytics as opposed to XDR analytics, but I often get the question, what is the difference between the two analytics engines? If we send NetFlow data to SNA and/or SCA, what is the functional difference? SNA, which has existed for a long time and formerly is called StealthWatch, has a number of different sets of outcomes on top of the data, and I'll talk more about these sets of outcomes later in the week, whereas XDR analytics is solely focused on threat detection. It is taking the data in, doing analytics, arriving at threat detection, as opposed to all of the other wonderful things that SNA does around network visibility and querying it and segmentation, visibility, and so on. And we'll talk a little bit more about that on my 3000 level session later in the week. Okay, so before I get into the final demo, or get into a demo in my final, is it 14 minutes left? I want to talk a little bit about the Meraki integration. So the Meraki integration with XDR was a long time coming. It took a lot of convincing of everyone involved that this is a thing that's really important. At a high level, it looks something like this. There is a dashboard level integration between Meraki dashboard and the XDR dashboard, which I will demonstrate. There is a Meraki Systems Manager integration, which allows data to go into device insights from Systems Manager. But what was new late last year, and then what will ultimately be expanded on through the rest of the portfolio, or the Meraki portfolio, as well as bringing in different data sets, is a direct integration between the Meraki devices and XDR, which is being able to send, today what that is sending all of what was formerly called, or the NetFlow logs on the MX, instead of sending them to an on-premise collector and having them forward to XDR, it's having the MX directly send them to the cloud and have them as part of XDR. And they're not actually, and I said formerly known as NetFlow, so the MX export is not NetFlow, it is flow logs in a different message format than NetFlow, but it is the same, it is an expanded data set. And I'll talk about that data set in a second. And then, so one other thing is security events is coming soon. We're working on that. I was hoping it would already be live for this event. And I was told last month it definitely will not be this quarter. So sometime later, we'll have the security events read over. Then when security events are read over properly, or MX security events will probably be first. But that largely, or logically speaking, is the same way we are going to look at processing intrusion, file, and malware events from FTD, and then those verdicts actually get into the IGF instead of going through the native SCA alerts and then into IGF. But that's some point in the future that will change. Okay, so there's licensing requirements. I won't talk about that. You do have to have licenses in order to do that. And also, most specifically from the direct to cloud upload from the MX, there is a platform requirement on the MX. Older platforms do not, so like the 64 or 65, are unable to adapt to the newer firmware, which is what the integration was built on. Okay. What made the Meraki integration so special and why I brought it in and kind of stuck it in at the end of my network analytics session, talk. One of the problems that we have always had in secure network analytics and anybody in the business of network detection and response is understanding IP addresses in the face of overlapping IPs. So if you are an organization that has multiple remote sites and you templated those networks and they all have the same IP space in all of those sites, this is not a very uncommon thing in the world, but you wanted to watch all of your sites from one network detection and response product or one single flow collector. The fact that 192.168, 128.100 exists in all of your sites created a functional problem. We were unable at an organizational wide level to be able to tell what site 192.168, 128.100 came from. This is a problem that has existed in the network detection and response market before anybody called it the NDR market. We've struggled with this problem on Stealthwatch side for over 20 years because it's functionally impossible to really tell the difference unless the network reports or the exporting device or the network that is reporting where it came from. And so what was really exciting about the Meraki integration, Meraki has built almost an entire business around this idea of templated networks and pushing that out to the different networks. And there is a fundamental rule in a Meraki network that there can only be one MX, two if you have an HA pair. But you're basically looking at a network edge. You can have one security appliance set. And that holds the network ID and the MX ID, which allows us to create a namespace and say this network is unique. So the integration with Meraki allowed us to solve a overlapping IP-based problem that has existed in network detection and response forever. So the combination of the Meraki, and so when I said it's not net flow data, it is telemetry that was designed to solve a very specific problem, this problem. So the Meraki telemetry includes the network ID and the IP address pair in it. So we know exactly what network it came from and the IP address of the host that was in said network, so that we can actually create a namespace entry, and you can see so in the SCA UI, you can see the namespace, and that defines the network or the logical location entity that we're monitoring. And so we have the Meraki, basically it's the network ID : serial number of the device, along with the IP address, creates the entity in the SCA. So we actually have solved a problem that was previously unsolvable. And so the Meraki XDR integration does two really fundamental things to the network detection and response market. One, it's currently the easiest to deploy NDR on the planet. 3 clicks, you can deploy a NDR into all those remote branches. And second, it solves an overlapping IP space problem that nobody else in the market has solved, which I think is phenomenally special. Okay, so with that, in a 3-minute window, I'll do a little demo. I think. There we go. So I'll start with the Meraki dashboard because this is super exciting to me. So the first thing is, in dashboard, you can actually see all of the XDR events. So the first level of integration between XDR and Meraki was to allow an incident to show up in dashboard. You can work an incident in dashboard. You can assign an incident to the people. You can change its state. And then you can choose to begin working the incident. So you can click on it. It will open this drawer. The drawer comes out. This is the exact same data it is the exact same data that is in XDR. Just calling it and showing it through a microservice. You can say click in it and view in XDR. Takes you over to XDR, where then you can look at the data. This is the AI summarization up here, the short description, long description. If we look at the detailed description, this particular incident, it began on May 28th, 2025 with a data hoarding alarm involving my bottling line with two findings. We can actually see that a user, Darren, connected to the bottling line using the PowerShell RDP thing that I mentioned earlier, downloaded large amounts of data. We can also see that there was DNS traffic to Tor proxy, more data loss occurred, and so on. And so you can actually see the description there, the different indicators, the alerts, the objects involved. And if you go and you look at some of the new demos, or some of the demos that are on the demo stand down below, and also what we announced at RSA. The storyboard here is going to begin to evolve slightly. As of right now, we're basically showing the grouping of objects that created the incident. The next step of evolution is going to be turning this into a storyboard that matches kind of our detailed description through time, so it's a little bit easier to follow an incident. But as right now, this is what it would look like in the UI. And then the best way of understanding what happened was to read that incident and look at the different indicators. I was mentioning right before the session that I had forgotten to make a slide of the feature that went live last week, which is this detection findings view. So one of the things that we're constantly asked for from an incident generation framework standpoint is the entailments or evidence that XDR took the data in, because sometimes XDR will take data in, but it won't show up as an incident due to the logic that I described for incident generation framework. So the detection findings view here is showing all of the detection data that XDR has collected. And so you can see some of these alarms here, like this is an endpoint event from Cisco Secure Endpoint that fired like an hour ago or so. Suspect data hoarding alarms and so on. So you'll see some, in this event, you'll see, or in this view, you'll see detections that come in that aren't part of an incident, and that'll link back to its original source, where it came from, and so on. As of today, there is no column that says what incident this particular detection is part of. Soon that column will come in. I don't know when exactly. I was hoping it came in when the detection finding view came in, but it did not. But soon. Right. I was just going to show what a single incident would look like as opposed to an enriched one. So a single source incident would look like something. So this was an incident that bypassed the incident generation framework. I just had a single detection, potential data exfiltration on host or Windows 11. This is just a single alert from the SCA dashboard that I promoted directly into the incident. So it will look slightly different just because it doesn't have the same volume of data in it from the incident generation pipeline. Okay. All right. Short demo. Okay. All right, so summary, we're at the end of the session. One hour to kind of walk through both the incident generation pipeline and the native detections is not a lot of time, but hopefully it's enough time to get an idea of what's kind of happening there. It's important you complete your session evaluations. We take them seriously. It's important that you continue your education. That's the whole point of being here. Okay, there are related sessions. Actually, I'll break apart related sessions in two ways. This is what I call related XDR sessions. One of them happened right now. So I would encourage everyone to go and watch this recording. Some other ones going into the future. The threat detection and response learning map, this is somewhere in the learning map. It's worth looking at that. There's about 10 sessions that are all related from an XDR standpoint. If you're interested more in just like the network analytics components, so this is SNA/XDR for XDR analytics for network detection. There are 5 sessions this week on that topic. This one over here in the top right in the magenta color is the one you just listened to. Tomorrow I have one about how to configure NetFlow. I have one on Wednesday that's more how the analytics of SNA work. There is a session on Thursday about integrating SNA with Splunk. And then tomorrow, at the exact same time as my how to configure NetFlow session, there's a how to architect an SNA deployment session that Hannah Jabbour is doing. I would encourage you to go to all of these because they're awesome. Okay, so my parting thoughts of the day. One, XDR is a security operations efficiency tool. The native detections that we produce are largely behavioral-based detections based on network activity. NVM, NetFlow data are really good examples. And the Meraki integration with XDR is something that's really, truly quite special. And because it is a real thing that happens at Cisco Live, and you need to keep your eyes open and don't have your beer stolen. It does occur. That is me at a Cisco Live, where I did once have a beer, and somebody took it. Okay, and so with that, thank you for listening to me talk for an hour. If you have any questions, I believe I have to vacate the room and do them in the hall because somebody else wants in here really quickly. But I am around. Thank you.